All right, welcome to 9.6 day 2. As a quick review, I want you to turn to your partner real quick, review with them what the quadratic formula is, talk to each other about what do you need to remember to check first, why are parentheses important, how do you determine A, B, and C, the steps to solving. I want you to just take a second and review and refresh and be ready to go. I know the video just started, but go ahead and pause the video, and then we will come back here in just a little bit after you've talked. All right, welcome back. So we're going to, we have our quadratic formula, right? If you don't remember it, you can write it at the top of the page or something. Remember, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to apply that to real life today. And real life could be something as simple as throwing a ball. It could be if you watch some YouTube videos of people who chuck a basketball or a big medicine ball off of the top of the Hoover Dam and wait for it to bounce. That would be an example of a parabola and solving it in real life, and they're trying to figure out how far away it's going to land, stuff like that. Other things such as playing those old battle tank games where you need to fire the projectile up in the air and hit your opponent. All those things are modeled by quadratics, and we solve them with the quadratic formula. So let's get right to it. We start out, is our equation in standard form? Yes, it is. So we just go ahead and use the quadratic formula. A is negative 2, B is 1, and C is 3. Okay, and just like yesterday, we plug them in. So negative b, so negative 1 plus or minus the square root of, doing this with the mouse is kind of hard, b squared minus 4 times a, which is negative 2, times c, which is 3, all over 2a, which is negative 2. Okay, I'm going to reduce this picture because we don't need it in our way. All right. Our next step, we got negative 1 plus or minus square root. 1 squared is 1. Negative 4 times negative 2 is 8. 8 times 3 is positive 24. All over negative 4. Okay, and so we keep going. Negative 1 plus or minus the square root of 25 all over negative 4. Okay, this one might work out nicely for us because the square root of 25 is 5 all over negative 4. Now if you remember, here's where we split it up. We have negative 1 plus 5 over negative 4, and we have negative 1 minus 5 over negative 4. Okay, and we solve each one individually. This would be 4 divided by negative 4 divided by negative 4, which is negative 1. That's one of our answers. Over here we have negative 6 over negative 4, which is positive 1.5 if you get your calculator out. Okay, now yesterday we were done, but now we have context, right? Jacob is tossing a ball across the playground. The arc of the ball can be modeled by that equation, where x is the horizontal distance in meters from Jacob. How far, our question asks, how far from Jacob does the ball land? When we have a real story problem, one of these answers will not make sense to our problem. Okay, if he throws a ball, is it going to go negative 1 meter? Obviously if he throws it backwards, but let's not nitpick here. This answer does not make sense in our problem. And so our problem, it's going to make, the one that makes sense is 1.5. So how far does he throw the ball? 1.5 meters would be our answer. Okay, in our problem, one answer will make sense. Now, if we look at this parabola, this would be 1.5 where it hits the ground again. And then if we go all the way back he started here, but if we keep the graph going, the ball would, if it, if we were able to reverse it, it would land on the ground 1 meter behind him. Does that make sense? And so the one that makes sense is the one in front of him, the 1.5, but the negative answer is actually what's behind him. All right, Jacob's going to stay with us today. Your worksheet is far more entertaining. I tried to mix it up and vary it with some real world examples other than Jacob. But here we go. Negative. First off, is it in standard form? We're asking the same question: how far from Jacob does the ball land? We have -2 for A. It is in standard form. -2 for A. B is 5. C is 4. Okay. I'm going to pause the video and you set it up, and then we'll come back together. All right. Check your answer with mine. Make sure we got the same thing. Sorry for my sloppy mouse handwriting. We have -5 plus or minus. Okay, let's start to deal with what's inside here. 25. Then this -4 times -2 is +8. Times 4 is 8 times 4 is 32. All over -4. Okay, and we just solve these like normal, like we have been doing. 25 plus 32 is 57. That's not a nice square root number. Okay, and then it's at this point, since 57 is not nice, we have -5 plus the square root of 57 over -4, and -5 minus the square root of 57 over -4. Okay, calculators at the ready. -5 plus the square root of 57. Oops. Pushed the wrong button here. Hang with me. All right, we're back with it. All right, and divided by -4. So here we get negative 0.6. That's one of our answers. Our other answer, if we do -5 minus the square root of 57 divided by -4, we get 3.1. Now, how far from Jacob does the ball land? It only makes sense that it's our positive one of 3.1. Still in meters? Yep, still in meters. So go ahead and tack on your label. 3.1 meters. All right, last problem here. Standard form, yes it is. Our A value is -0.5. B value is 3, and C value is 5. I will let you and your partner work on this. So go ahead and pause the video, and then we'll come back together to check. All right, so welcome back. Go ahead and take a second, just check your answer. I plugged in all my numbers as I normally would, and I took it step by step. And I ended up with -3 plus or minus the square root of 19 over -1. And then I split it up. And one of my answers was -1.4. The other was +7.4. I forgot my label, meters. Because it's still in meters, yep. So my answer that makes sense is that it landed 7.4 meters in front of me. Now, we have to, it's not always the positive number, right? Usually it is. However, if the problem said how far, maybe if this said behind, if that is not how you spell behind. You know what I mean. If the problem said, Jacob is bowling, and those people who they go to throw the bowling ball and it goes backwards, right? Jacob is going bowling and he threw the ball, but it went backwards. How far behind him did it land? Well, that problem would actually be asking for the negative answer, right? The answer would be behind him right here, the -1.4. All right, so you have to read the problem, figure out what it's asking, and select the correct one for what the problem is. All right, typically it'll be your positive answer, but I don't want to make that a hard and fast rule because there will be times where it's not. All right, you have a worksheet to be doing, real world examples. I tried to make them as interesting and applicable as possible. So just some more practice with solving with the quadratic formula. There is a front side and a back side, so you're aware. All right, thanks guys.